Okay, so it's a closed. We all highlighted closed, correct? Okay, so a polygon is a closed plane figure formed by coplanar segments called sides such that, and it has 3 requirements. Guys, before we jump into the requirements, what does coplanar mean again?
On the same plane.
On the same plane. So, in other words, look at the whiteboard, okay? All of your figures are going to be how many dimensions? How many dimensions was a plane? It's not 3, 2. If you're watching a movie, right? You normally watch movies in how many dimensions? 2. When you get the goggles and it becomes 3D, it's because what? What happens? Stuff jumps out at you, okay? So 2 dimensions, it's going to be on a plane. All of our figures that we're looking at in this chapter will be 1-dimensional figures that we look at on a plane. Got it? Okay. So it says number 1, the criteria. Each side must intersect exactly 2 sides, 1 at each endpoint. What the heck does that mean? Draw a picture. Draw a side of a figure and draw 2 other sides that intersect that figure. All of your sides must look like this, okay? Do you see how the side in the middle, I will highlight it. Do you see how it intersects 2 other sides? It intersects this side here and this side here. No more, no less than 2. We Gucci? Okay. Step number 2, no two sides with a common endpoint are collinear. No 2 sides with a common endpoint are collinear. What that means is you cannot have the figure have a side like this, where there's 2 sides right next to each other forming one line, okay? Do you guys see that? You cannot have a side where there's a point in the middle of your side, okay? It needs to have points on the ends only, okay? This is a no-no. Put an X, okay? Each endpoint of a side is a vertex of the polygon. In other words, you should always have a corner, okay? You should always be having corners. If your figure doesn't have a corner, okay, it's not a polygon. Now, all of this is fine and dandy, but it makes very little sense to you guys right now, and I understand that. But let's look at some figures, okay? So go to the next slide. We're going to identify which of the figures are polygons and which ones are not. So in example A, would you guys say this is a polygon or not a polygon? Is it closed? Yeah. Does it all of its sides connect to 2 other sides? Yes, it satisfies all of the criteria. It is a polygon. Yeah. Yes, go quick. 5 minutes. 25. We Gucci? Take a look at B. What's different about B, guys? It's open. So if it's not closed, is it a polygon? Put a big fat no. Not a polygon. And just write a note to yourself that it is open. Okay? Then take a look at C. Is C considered a polygon? Hayden? Why not? Very good. It's no, because look at these 2. Do you see how their sides cross over each other? Yeah. First of all, polygons cannot have sides that have additional endpoints. Do you guys see that? It has to have one endpoint here, one endpoint here. But here you see sides crossing over each other. That's a big no-no. Secondly, doesn't it also intersect more than just 2 sides? It intersects this side, this side, this side, and this side. Okay? That's a big no-no as well. All right? So this is definitely not a polygon. Is D a polygon? Yes. Okay? It is a polygon. Is E a polygon? No. This one's a little bit hard to get into like the nitty-gritty, but does it look like a closed figure in E? No. That's how I would say it's not a polygon. It's very open, right? It's just like 3 lines basically. So this one is not a polygon. Are we Gucci? Mm-hmm. Okay, excelente. Questions so far? Perfect. Now, when we're dealing with polygons, there are some types that we need to know. We need to know whether they are convex or concave. Do you see how I highlighted the X? EX here. Do you guys see that? Yeah. Draw a little note to yourself. EX stands for exterior. Okay? EX stands for exterior. This is how I remember it. You don't have to use this. I recommend that you use this though, okay? It means that no line contains a side of the polygon. No line that contains the side of the polygon contains a point in the interior of the polygon, okay? Do you guys see the figure that they gave you with all the red lines? Do any of these red lines go inside the figure? No, they stay on the edge. That's called exterior. Do you guys agree? This is a convex polygon. Draw, for the one on the left, draw the 5 lines on the exterior of the polygon. Do you see how none of them go inside the figure? Those are considered exterior polygons, okay? The same would happen if you did it with the one on the right. Questions on what a convex polygon is? Okay, so what does X stand for again? Exterior, okay? Now, moving on to the next one, we have something called a concave polygon. What do you do when you get to the cave? You go inside, okay? Inside. So for concave polygons, it has a line that contains a side of the polygon that contains a point in the interior of the polygon. Do you see how this red line, it goes inside the polygon? It goes inside, it's concave, okay? It's concave. It goes inside. Now, for the last one, please draw the two, in red, the 2 lines. Do you see how both of these also go inside the polygon? Okay, this would indicate that it's concave. Just by looking at the figures, guys, what do you notice about convex versus concave? Could you describe it in other words? Yeah, Hayden?
They look more like regular shapes.
Irregular shapes? Yeah. Concave are more irregular. I agree with that. Convex are more like standard, like an octagon, a hexagon. What else? Yeah, Carson? More points? Yeah, kind of like dips inwards. Yeah, I like that. What else? Cody? The other ones are like boxes. Yeah, they kind of remain exterior. Okay, good. Do you guys see the difference? All right, let's do some examples. Okay, this is just a classifying polygon slide. I'll get back to this in a second. We'll give you this on the test. Okay, you need to have this memorized by chapter 3. Okay, but for this test in chapter 1, I will give you this sheet. Gucci? Polygon slides. Notice, what number is skipped here? 11, okay? We call an 11-sided figure an 11 gone. If it's got 13 sides, it's a 13 gone. 14 sides, 14 gone. So anything past 12, including 11, would be called that number and then gone. Understood? So how many, if it was 47 sides, what would we call it? 47. A 47 gone, okay? Now, if it's 12, it's dodecagon, 10 is decagon, 9 is nonagon, 8 is octagon, 7 is heptagon, 6 is hexagon, 5 is pentagon, 4 is quadrilateral, and 3 is triangle, okay? Do you need to have these memorized for the chapter 1 test? No. Well, you have to have them memorized by chapter 3? Yes, okay? But jump to the one where it says A, B, C, and D. Do you guys see that slide? Okay. Tell whether the figure is a polygon and whether it's convex or concave. Take a look at A. Is this a polygon?
No.
It is not. Does anyone know why, though? John?
I was going to say there's a line in the middle.
Very good. Please highlight that line, guys. Why does this line in the middle make it not a polygon, though, John?
Because like it separates it.
Very good. How many sides does that line in the middle intersect? 4. It intersects this one, this one, this one, and this one. Do you guys see that? Can it intersect 4 sides? No. How many can it intersect at most? 2. How many at least? 2. Has to be 2. We Gucci? Okay. So it's not a polygon. If it's not a polygon, it's not convex or concave. Got it? Okay. B. Polygon. Yes, this one is. Convex or concave? Convex. Very good. Why is it convex? They stay on the outside. Do you see it? Do you hear it when you say convex? X, exterior. You got it? Cool. C.
I got it.
John?
It's not a polygon.
Ooh, this one's not a polygon. Why?
It's bending.
Very good, okay? Please highlight, circle, whatever you need to do. It cannot be curved, okay? It cannot have a curve to be a polygon. Okay? The definition says they have to be segments. They have to be segments. They cannot have a curve anywhere. Are circles polygons?
No.
No. Are ovals polygons?
No.
Are hemispheres polygons? No. Okay? Anything with a rounded edge is no bueno in the polygon world. Okay? It's like Mean Girls. They can't sit with us. Okay? All right. D. Polygon? Yes. This one is a polygon. But is it convex or concave? Cody? Why? Because it caves inwards. Do you guys see if we were to draw red lines, they would go inside our figure? Boom, bada bing. Pretty simple so far, right? Just wait till we get to the end. Hey. All right. Are we good so far? Okay. Moving on. Classify the polygon by the number of sides. Tell whether the polygon is concave or convex. Now, these diagrams have a bunch of different symbols on them, okay? Please don't get intimidated by this. All these symbols mean, we have seen this symbol before, this little line. What does that little line mean? It means congruent. So all of these sides are what? All of these sides are the same what? Length. All sides are same length. Okay? And draw a little arrow next to that mark. Okay? Now, the curved arc, we'll get to that later, but that just means that the angles are the same measure. We'll talk about the meaning of that later, okay? You do not need to know that for now, okay? All you need to know is that that one symbol, that straight line, means that it's the same length. We Gucci there? Okay. How many sides does this figure have? 6. So 6 sides. Does anyone know what a 6-sided figure is called? Yes. It's a hexagon.
Interruption. Robert Diaz reports to services. Robert Diaz reports to services.
Okay, so it has 6 sides. It's a hexagon. Is it concave or convex? Convex. Why? Very good. Convex. None of those sides, if we were to extend them, would extend into the interior. They would all stay outside. Do we see that? Is anyone confused on that? Okay, excellent. B. I want you to make a note. Which 2 sides, they're not all the same length. Which 2 sides are the same length? Yep. Excellent. Let's exaggerate that by highlighting it. So take out a highlighter. Highlight these 2, the top and the bottom ones, in red, and highlight the other 2 in blue. Okay? This is what we call a parallelogram, okay? Its opposite sides are the same length. You don't need to know that it's a parallelogram, okay? All you need to know is how many sides it has. How many sides does this guy have? 4. So it's called a... Very good. So 4 sides. It's a quadrilateral. And concave or convex? Convex. Why? It's outside. Okay. None of these lines that you could draw would ever reach the interior. Do we agree? Oh, I'm tired. Questions? Yeah, Cody?
So we have to know, like, if it's a hexagon.
No. This one. Start counting. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Did we count 12 sides? Yeah. So 12 sides means it's what kind of figure? It's a 12gon, correct? No. What is it called? It's a dodecagon. Okay? Is it concave or convex?
Concave.
Concave for sure. Okay? Let's just draw just for us. Like, take side number 1 and extend it. Do you see how it goes inward? Okay? Now, if you did the same thing to side number 3, do you see how it would stay on the exterior? All you need is one that goes inside, and it's concave. Got it? Okay. Now, jump back to the done. Okay. This is the more challenging part of the lesson. Okay? So you want to put a note. This is where it gets kind of dicey. Okay? Just bear with me. Let's review perimeter and area. Okay? What does perimeter mean? Outer. Okay? It's the outside. I like to think about it as a fence. Okay? If you're building a fence, how much fence do you need to cover your entire grounds? Okay? What is area? It's the inside. I like to think about it as the space that it takes up. It's the space taken up. Okay? Let's do an example with the kitty poster. Do you guys see the kitty poster over here? Okay? Really cute on the tree. Okay? The perimeter would be the distance to go all the way around the entire poster. Do you guys see that? The area would be how much space this poster takes up on my board. Okay? So it's factoring in like, it's going to be in square units. It's going to be like how many little cubes can we put inside of here to figure out how much space this thing takes up. Perimeter, outside, areas on the inside. Gucci? Okay. What you guys need to know are the formulas. And you will be given these, but you need to know how to apply them. The perimeter of a triangle, you add up all 3 sides. The area of a triangle, 1/2 your base times your height. The base of your triangle will be from one endpoint to the other on that bottom side, and your height will be the line going straight up and down. Okay? So the height goes from the top of the triangle all the way down to the base. Is this height one of my sides of my triangle? No. Do you guys see that? Make a note of that if you need to, okay? A square has all congruent sides, so each side is the same. To find the perimeter, you take this side, any side, and you multiply it by 4, because there's 4 sides. Do you guys agree? All the sides are the same length, though. If you were to find the area, you take 2 of the sides and you multiply them together. Do you guys agree? So that would be side times side. In other words, side squared, okay? For example, if one side was 6 of this square, what would the area be? 36 units squared, okay? For area. All right, and now a rectangle is one where the opposite sides are congruent, right? But not all of them are the same. So you're gonna have a length and you're gonna have a width. The area is just length times width. The perimeter, since there's 2 of each side, you do 2 times L plus 2 times W. These are the 3 figures that we're going to see. Any questions about these 3 figures? Have we seen triangles, squares, and rectangles before? We should. Okay. All right. Let's do an example. Let's find the perimeter of ABC with vertices A, B, and C. Already, before we start, stop what you're doing. What kind of figure is this? Triangle. How do you know it's a triangle? There's 3 points, okay? So it's going to be a triangle. And we're finding what? The perimeter, right? So what do we do to find the perimeter?
You add all these sides.
Add all sides. Very good. Guys, it's not the 1.5 notes. This is 1.4 notes. We started these yesterday. Make sure when you put your points on your graph.
Did Carson Kroll get to class?
No.
No?
Nope. Someone marked her present. Okay. Once we plot our points, connect the dots. You should get a triangle that looks like this. Do you get a triangle that looks like this? Okay, then you plotted correctly. What are we finding here? What is it asking us for? The perimeter, okay? How do we find the perimeter of a triangle? Cody? Add all the sides. What's one of my sides?
Oh,
I heard 5. Which side is 5 units? Label it with 2 points. CB. So we're going to put CB here. Plus, what's another side of my triangle? Yeah, Cody?
AC, which is 6.
AC, which is 6. Very good. And the last side of my triangle? Cody? Okay.
AB.
AB. Check this out. The 2 easiest sides are CB and AC. Why are those easy?
Because they're not diagonal.
Very good, John. They are not diagonal. So we can just do what to find their length? Count, okay? So let's count it. 1, 2, 3, 4, 5, 6. Do you agree AC is 6 units?
Yep.
So in your equation, where it says AC, what are you going to put? 6. CB is how long?
5.
1, 2, 3, 4, 5. Do we all count 5? So this one's 5. Uh-oh. AB is the most difficult side because it's at what?
angle.
A diagonal. How do we find the length of a segment between 2 points?
You have to add the halves.
No.
You divide it by half.
No. Yep.
You divide it by
You
No.
multiply it by half.
No.
Do math.
It's a formula.
Oh, it's
Oh. Yeah? Yeah. What formula is that?
up one to the left, up.
The what? The distance formula. Write that down. Okay? We must use the distance formula for AB. I agree. CB and AC, those were cake. You could just count it. One of your sides is going to be a diagonal, and you must use the distance formula to find it. Are we clear? Okay. So, when we're using the distance formula, remember, always identify an x1 and a y1, and an x2 and a y2. Ava, do you want to make A, x1 and y1, or x2 and y2?
X1 and X2.
Perfect. X1 and y1. Okay? Make the same point, 1 and 1. Make the other point, that means B is going to be what?
X2 and Y2.
Perfect. X2 and y2. Okay? Now, our distance formula says to find AB, it's going to be the square root. Does anyone know what to write here? Mario?
Parentheses x minus x1 squared.
X2 minus x1. Good. Plus?
X y2 minus y1 squared.
Good. AB is equal to, what's x2?
3.
3. What's x1?
Negative 2.
-2 squared. Plus, what's y2?
Negative 3.
Minus y1
3.
squared. Have I lost you? Okay, we're Gucci so far?
Yes.
All right, now it just becomes a little bit of algebra and negative signs. AB equals the square root. What's 3 minus -2?
5.
5, thank you. Squared. Plus -3 minus 3. It's not 0, peeps. -6 squared. You guys with me? 5 squared will give me what? So I have the square root of 25 plus, what's -6 squared?
36.
36. 25 plus 36 gives me
51.
61. Ronnie?
Would you be able to do as like C? Like would you like for x1 and y1?
No. Because C is a different point. Do you see that? We're finding this distance, so we have to use those 2 points. Make sense?
Yeah.
Okay. So we got the square root of 61. So in our equation where we see AB, put plus the square root of 61. And our perimeter, we can combine which 2 of those? The 5, the 6, or the square root of 61? 5 and 6. What's 5 plus 6? 11 plus the square root of 61. Guys, whenever you get a square root, you're going to leave that as part of your answer. Are we clear? Okay. So our answer is 11 plus the square root of 61. Gucci? Now, does the square root of 61, does it simplify at all? Are there any perfect squares? My perfect squares are 4, 9, 16, 25, 36, so on and so forth. Are any of those factors of 61? No, so we're done. We leave it the way that it is. Yes, Cody.
We would simplify it.
You would simplify it if you could, okay? Let's simplify one. Guys, find space. You can add a page or something. Let's simplify a few radicals so we get in the practice of that. Let's take the square root of 20, and let's take the square root of 128. No. No. 18. Okay, take a look at 20. Is there a perfect square that's a factor of 20? German? 4. So we're going to break 20 into the square root of 4 and the square root of what? 5. Do you guys see that? Because 4 times 5 gives me 20. I brought out the 4 for what reason? Because we know the square root of 4. What's the square root of 4? So this becomes 2 times the square root of 5. Do you guys see that? This is our final simplified answer. Gucci? Okay. 18. Does it have a perfect square? That's a factor. 9. Excellent. So we're going to break this up into the square root of 9 times the square root of 2. The square root of 9 is 3. And the square root of 2 is? No, it's not. Do we know the square root of 2? Leave it. Do you see how part of our answer is a number, a whole number, and part of our answer is a radical? This is how I want you to leave it. We will do more practice with this. The people that had me last year, you know how much practice we did last year, okay? All right, questions on that? Let's do another one. Yes, y1. All right, find the perimeter of, we have a different figure now. What kind of figure is this going to be? Not necessarily a square, a quadrilateral. Thank you, Mario. Once we plot it, we can see whether it's a square. A square specifically has all congruent sides, right? We don't know that yet. We have to plot it. So plot the points. Go. Put your points on your graph. This is -3, 2. Oh, -3, -2. This is 2, -2. This is 4, 1. And this is -1, 1. Okay? Does your graph look like this? It is a quadrilateral. Is it a square? No. Okay? Is it a rectangle? No. Okay? 2 of the sides are going to be very easy to find the length of. Which 2 sides will be easy? Cody?
KL and NM.
Very good. Why are KL and NM going to be easy? John?
It's straight.
It's straight, okay? You can count it. So, from N to M, how many units is it? 1, 2, 3, 4, 5. From K to L, how many units is it? 5, okay? So, we're finding what? What's this problem asking us for? Perimeter. So perimeter is going to be KL plus LM plus MN plus NK. All of the sides added up. Do you guys agree? We know that KL and NM are both going to be 5 units. So we're going to say perimeter equals, we're going to replace this with a 5 plus LM. We don't know that diagonal one yet. plus mn, which is 5, and then plus nk, which we don't know. So we're going to leave that one in there. Are we cool so far? Questions? All right. How are we going to find LM and NK? John?
Distance formula.
Thank you, John. We are going to use the distance formula. Now, are LM and KN going to be the same length?
Yes.
Yes, they are. Okay, so we just have to find one of them and then multiply that length by 2. Okay? Because we have 2 of those lengths. Okay? So let's do LM. You could have used KN, but let's just use LM. Okay? Make one of your points what? X1 and Y1. Make your other point X2 and Y2. I'm using L as X1 and Y1, and I'm using M as X2 and Y2. And then write your formula. It's going to be the square root of 2, which is X2, minus X1, which is 4, squared, plus Y2, which is negative 2, minus Y1, which is 1, and then we're squaring it. Oh, baby. LM equals the square root, 2 minus 4. Negative 2. Negative 2 minus 1. Negative 3. Okay, we're squaring both of those. So LM is going to be the square root. Negative 2 squared. Positive 4. Negative 3 squared. Positive 9. What's 4 plus 9?
13.
Square root of 13. Look to simplify. Is there any factor of 13 that's a perfect square? No. 13 has only factors of 1 and 13. Neither of those are perfect squares. Actually, 1 is, but we're not going to use 1. Okay? All right. So we have the square root of 13. We're going to replace LM and NK with the square root of 13. So our perimeter is equal to 5 plus the square root of 13 plus 5 plus the square root of 13. Because these two lengths are the square root of 13. I'm going to pause here. Are there questions on what I've done so far? On the process? We're Gucci? Give me a thumbs up if you're okay with what I've done so far. Okay, awesome. All right. All we have to do is simplify this. What can I combine in my perimeter statement? The 5 and the 5. Highlight them using one color. Okay? 5 plus 5 should give me what?
10.
So we're going to write 10 plus, if I have 2 square roots of 13 and I add them together, what am I going to get? It is not the square root of 26.
Oh, that number squared, so 13.
No, it's not going to be 13 squared. Yes. Nope. 2 times the square root of 13.
Wow.
Let's see why. Guys, this is very important. Please write a side note over here. This is super important. If you have y plus y, does that give you y squared?
No.
No. What does it give you? 2y. If you have y times y, that gives you y squared. Do you guys see the difference? This is mega important. Importante. That was a great question. Write this down. If you have the square root of 5 plus the square root of 6, this does not equal the square root of 11. You cannot add 2 square roots together if they are under separate radicals, okay? If they looked like this, 5 plus 6 underneath the same radical, could you add them together now?
Yes.
Yes, now this would give me the square root of 11. Know this difference, okay? Properties of radicals is something we dealt with last year, okay? In algebra, if you need a refresher, that's what you should write this down, properties of radicals. You can look it up. Khan Academy has great stuff, whatever you need. Yeah, John.
Can I use the bathroom?
Yes. Let's do the last really quick. All right. Area of the triangle DEF. Super duper important. Oh my gosh. Okay. I almost forgot. Guys, on your homework. Actually, you guys aren't, is this one's a PDF, right?
Yes.
You can ignore this no, okay? You're not gonna use a calculator for your homework, okay? You're gonna leave everything as a square root. Got it? Okay. Find the area of the triangle DEF, okay? So plot your points. D is at 1, 3. E is at 4, -3. And then F is at -4, -3. Remember, we are finding something different in this problem. What are we finding? Area. And what kind of figure is it? A triangle. So we're going to say our area is 1/2 base times height. Do you guys agree? Okay. Make sure that you put the points and you label them. So this is 1, 3. This is 4, -3. And this is -4, -3. Okay. What's my base here, guys? Which side is my base? FE, very good. How is FE easy to find? Why? It's a straight line. Can we just count it? It's 1, 2, 3, 4, 5, 6, 7, 8 units. You guys agree? So B is equal to 8. What is my height? Start from which letter? Macy? Very good. Start from the top and go down to what? The base. Do you guys see how we've created a straight line?
Yes.
Okay. What can we do with straight lines to find their length? Count it. So it's 1, 2, 3, 4, 5, 6. Do you guys agree that my height is 6? So if B is equal to 8, H is equal to 6, could you figure out the area? How? Yep.
1/2 times 8 times 6.
1/2 times 8 times 6. So area is going to be equal to 1/2 times 8 times 6. This will give me 1/2 times 8 is 4. 4 times 6, which is 24. Now, be very careful. What units is area in?
Meters. Yards.
Did it tell us whether this was meters, yards, or anything?
No.
No. So we're going to put its random units. But what do we have to do with the units? Square it, okay? Area is always with units squared. Perimeter will be a one-dimensional unit. So you'll just have the length. So if it's inches, you use inches. If there's no units given, you just put units. Gucci? Okay.